Okay, in this video, we are just going to go ahead and go over a review of some basic right triangle trigonometry. And that is going to kind of revolve around sine, cosine, and tangent. And the way that we learn these is that we were to go ahead and all of what we would have when we're talking about taking the sine or cosine or tangent of an angle is the position of the angle. So you can see in the leftmost triangle here we have theta, okay? And theta just basically is a variable that oftentimes represents an angle. And from theta, the sides from that would be, the opposite side would be the one that it opens up to. The hypotenuse is always going to go ahead and be the longest side, or the side that's across from the right angle. And then the adjacent side is the one that is left, okay? Now, if the angle would switch places, so for example, if I looked at over here, alpha, which is another common name for an angle, notice that this side would be the opposite that the angle opens up to. The hypotenuse is going to stay the same, as it's always across from the right angle, and the adjacent is the one that is going to be left, okay? So let's go ahead and take a look at how we're going to use these. But before we do that, some skills that we're going to need are some calculator skills, and we're going to have to take a look at the Pythagorean theorem. I'm not going to go through the Pythagorean theorem again, as you can go ahead and scan the QR code, which is right here, and that will take you to just some regular brush up on Pythagorean theorem practice, okay? What we do want to do is that with our calculators, we want to make sure, and this might be a little bit different, and I'm trying to get another video going that's going to show how to set up your calculator for this. But with your calculator, if you're using just a regular TI-30 or if you're using a TI-84, make sure that your calculator is in degrees, okay? And it usually says, if you have a calculator screen here, and it's usually going to say something like DEG on there. If it says RAD, that's radians, and we're going to get to that later, but we don't want that right now, okay? So for our calculators, what we want to do is that we want to find the sine, cosine, and tangent, which are going to go ahead and just be like this right here. Okay, and when you plug them in, basically you would hit the sine button, okay, and then the parentheses, and if it's in degrees, you just put the 48 in there, and you would do the same for each one of these separately, okay? So, asking my calculator, this is what I got, and let's take this out to 3 decimal places here. So, those values are these kind of ugly numbers right here. And you know you're doing it correct is when you punch those into your calculator, and that's what you get. If you got something different, you might be in radians, and you might have to switch on over to degrees. If you have a problem with that, you can go ahead and ask, and I can help you out getting your calculator in the correct mode. So, all right. So what we're looking at is this business of sine, cosine, and tangent. And one way that we can remember these is the acronym, because we're going to be using the ratios of the sides here. So we can use SO, and then CA, and TOA. Okay, and basically it is going to go ahead and do a play on what this these definitions are right here, okay? So when I look at this, the SOH is going to be sine equals opposite over hypotenuse, okay? So it's just a way to remember that. So sine of some angle is going to be, and I'm just going to put whatever, angle X is going to be the opposite over the hypotenuse. Cosine is going to be C a h, that's where the ka comes from, if you will. And so the cosine of some angle is going to be the adjacent side over the hypotenuse. And then finally TOA, which is going to be the same deal here. Tangent equals opposite over adjacent. And that is going to give me the tangent of x equals the opposite over adjacent. Okay, so what we're going to do first is that oftentimes we're going to get a triangle like this, and we want to find all these trig ratios that are listed here on the right-hand side. One of the things that we want to do is, before we start here, we notice that C is not given here. So let's run through the Pythagorean theorem real quick and knock out that C value, okay? Just so we have all the sides, and that's going to set us up to do our trigonometry correctly, okay? So it looks like we're going to have 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. 25 equals C squared, and we take the square root of both sides, and we're going to take the positive part of the square root because it's a length, and we get C equals 5. Okay, that looks like a 6. Sorry about that. So C equals 5. And so we have all the values, and now we can start answering these questions. So it says sine, which of A. So first thing I'm going to do is that I'm going to locate A right here. And I know that sine is going to be the opposite side over the hypotenuse, which is the longest side. So I would write then the opposite side, I don't know why I erased that, over the hypotenuse, which is going to be 4/5. Okay? So if I wanted to do the cosine then from A, I'm going to use the same position of the angle, but I would have the adjacent side, which is the one that's left, that's not the opposite or the hypotenuse, over the hypotenuse, which is going to give me 3/5. Okay? And then finally, I'm going to take a look at this business of the tangent, which is the opposite over the adjacent. And so that's going to give me 4/3. Okay. So everything changes if we go ahead and we do the second angle that's available to us that's not a right angle, which is angle B. All right? So now we're switching to the sine, cosine, and tangent of angle B. So now the sine is going to be 3 opposite over hypotenuse, which is 5. So that's going to give me 3/5. Okay? And then we're going to go ahead and do the adjacent, which is, or the cosine, which is adjacent over hypotenuse, which is going to give me 4/5. And then finally, I'm going to get tangent, which is going to give me the opposite over the adjacent, which is 3/4. Okay? So now that everything's done here, let's take a look at these, just something that's going on. Take in mind that the sine of A, and this is just looking at some properties lightweight here, is that the sine of A is the same as the cosine of B. Okay? Pretty interesting. And the cosine of A is the same thing as the sine of B. Pretty interesting. And we also have the tangent of A. Its reciprocal is the tangent of B. Okay, and so we're going to take a look at those properties more in the future. Pretty interesting stuff for now, but that's how you set up the trigonometric ratios. And then it says to convert them to the decimal equivalents. I'm going to do that real quick so we can see that part, and then I will see you in the next video. Okay, so just completing the process again. Here's the decimal equivalents. So now I'll see you in the next video.